All right, if you guys would grab out your quiz review packet, and we're going to take a look at our all of our questions that we have. Okay, so maintaining a balanced quiz review. So use the pan balance to answer each question. What will balance one rectangle and explain your strategy? Then it says use the symbols to rewrite the representation shown on the balance as an algebraic equation. Let each rectangle equal x and each square equal 1. So, and then solve our equation for x. So we're going to do both of these in the same sentence. We're going to actually write the equation, solve it, and that's going to tell us what is going to balance one rectangle. Okay, so I am told that each rectangle is represented by x. So I see that on the left side, I have two x's. It tells me that each box is representing by 1. So each individual box is represented by 1. So I have two x's on the left plus 5 positive ones on the left. This right here means equal because I'm balanced and I need to see how many ones I have. Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 2x plus 5 is equal to 13. Now, we need to solve our balance to see what does one rectangle equal. So remember, when solving two-step equations, you're going to either add or subtract first, then you're going to multiply or divide. So the first step, I see addition, so I'm adding 5. I'm going to take away 5 from both sides. 5 minus 5 is 0. I'm left with 2x on the left side. 13 minus 5 is 8 on the right. I do not see any more addition and subtraction, so now I need to multiply or divide. Well, 2x is 2 times x, so I see multiplication. The opposite or the inverse is division. So I'm going to divide by 2 on both sides. 2 divided by 2 is 1, so I'm left with 1x, or just x, is equal to 8 divided by 2 is 4. So one rectangle contains 4 boxes. All right, let's try for number 2. I'm given the same situation that each rectangle is worth x. So I have 2x plus each box is worth 1. 4 is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is equal to 10. All right, so I'm going to rewrite it down here to have a little bit more room to write. All right, so same concept as up here. I'm going to add or subtract first, then multiply or divide. So I'm going to do the opposite of what I see. So I see addition, and the inverse is subtraction. And what you do to one side, you must do to the other. So I'm left with 2x on the left is equal to 10 minus 4 is 6. I see multiplication, so I need to divide by 2 on both sides. 2 divided by 2 is 1. To have x is equal to 6 divided by 2 is 3. To give me x is equal to 3. All right. Here we go. Solve each equation, show each step, and check your answer. Okay. So I'm going to give us our little key up here just in case we need it again. You're going to add or subtract, then you're going to multiply or divide. Write that at the top of your paper and go back to refer to it when and if you ever need to. All right, so I got 8x minus 3 equals 37. Well, the opposite of subtracting 3 is going to be to add 3 to both sides. So I'm going to add 3 to both sides. Negative 3 plus 3 goes away. I'm left with 8x is equal to 40. I see multiplication, so I need to divide. And I'm going to divide by 8 on both sides. 8 divided by 8 goes to 1. So I'm left with x is equal to 5. All right, number 4. Number 4. 5x plus 26 equals 9. All right, so I see adding 26, so I need to subtract 26 on both sides. 26 minus 26 goes away. I'm left with 5x is equal to, well, I need to do 26 minus 9. So I'm going to do 26 subtracting by 9, and I get 17. Now, this is not a positive 17 because I had 9 positives and 26 negatives. This is a negative 17. I'm going to divide by 5 on both sides. 5 divided by 5 is 1, which is going to leave me x is equal to, well, a negative divided by a positive is a negative. And I'm going to come over here off to this side. 5 can go into 17 3 full times with 2 left over. Goal in division is to get to 0, bring down a 0, add a decimal and bring it down. 5 can go into 20 4 times with nothing left over. So x is equal to negative 3.4. Okay, so I'm going to actually go back to number 3 because it says to check our answer, and I forgot to do that. That means I'm going to take my answer and I'm going to plug it back in to check to my equation. So instead of x, I'm going to plug in 5. So I'm going to have 8 times 5 minus 3, and I should get 37. Well, 8 times 5 is 40, minus 3 equals 37. Well, 40 minus 3 does equal 37, and this is correct. You guys can put question marks if you want. Okay, so let's go ahead and check number 4. So I'm going to plug in negative 3.4 in for x, add 26 equals 9. So this is what I want to know. Does it equal 9? Well, 3.4 times 5. 5 times 4 is 20. 5 times 3 is 15, 16, 17. I have one place value, so I'm going to move it 1 time to the left. And it's a positive times a negative, so it's a negative 17 plus 26. And I want to know, does this equal to 9? Well, take a look. I have a negative and a positive, so I really need to subtract my two numbers. So I'm going to go over here. Yep, y'all can still see. I cannot do 6 minus 7, so I need to borrow and carry. I can do 16 minus 7, and that's going to get me 9. And 26 was bigger, and it's positive, so it's 9 is equal to 9. So 3.4 is our true answer. All right, let's look at number 5. 3x minus 4 equals 32. I need to add 4 to both sides to give me 3x is equal to 36. I'm going to divide by 3 because I see multiplication. 3 divided by 3 goes to 1. I'm left with x is equal to 12. Let's double check our answer. 3 times 12 minus 4, does it equal 32? 3 times 12 is 36. And is 36 minus 34 32? It is. All right, number 6. I see adding 5. I see addition, so I'm going to subtract. 5 minus 5 is 0. Now I'm left with 7x is equal to, if I start at negative 5 and I'm taking 5 more away, so I have a negative minus a positive, I'm going to add these two numbers and I'm still in the negative because I start at negative 9 and I'm going 5 more into the negative. So I have 2 of the same sign, so I'm going to add them and it's still going to be negative. I'm going to divide by 7 on both sides. I'm left with 1 or x. A negative divided by a positive is a negative, and 14 divided by 7 is 2. All right, let's check our answer. So 7 times negative 2 plus 5 Does it equal negative 9? Well, 7 times negative 2 is negative 14 plus 5. Now see, I have two numbers that are opposite values. So I'm going to subtract my two numbers. And when I do 14 minus 5, I do get 9. Well, negatives, I had more negatives, so it's negative 9 is equal to negative 9. All right, number 7. 3x minus 21 equals 30. Well, I see minus, so I have to add 21 to both sides. I'm going to get 3x is equal to 51. I need to divide both sides by 3. And 3 divided by 3 is ended up being 1. So x is equal to, well, let's see. 3 can go into 5 one time with 2 left over. Bring down my 1. 3 can go into 21 7 times with nothing left over. So x is equal to 17. All right, let's double check our math. So I'm going to do 3 times 17 minus 21. 3 times 17. 7 times 3 is 21. 3 times 1 is 3, plus 2 more is 5. 51 minus 21. One minus 1 is 0. 5 minus 2 is 30. And 30 does equal 30. All right, number 8. 8x minus 9 is equal to negative 41. All right, well, I see minus 9, so I need to add 9 to both sides. I'm left with 8x on the left is equal to, well, I have a negative 41, and I'm adding 9 positives. So I have two numbers of two different values, so I really need to subtract. So I need to borrow and carry. 11 minus 9 is 2. 3 minus 0 is 3. So I'm left with 32. And this is a negative 32 because I had more negatives. I need to divide by 8. Goes to 1. To have x is equal to 4, and it is negative 4. All right, so let's go back and plug in and check. 8 times negative 4 minus 9 is equal to negative 41. 8 times negative 4 is negative 32 minus 9 is equal to negative 41. Okay, now I do have a subtraction problem going on right here. So what I need to use is I need to use keep, change, change to turn this into an addition problem. So I'm going to keep the first term of negative 32, change subtraction to addition, and I'm going to change the value of 9 to negative 9. And now I can see what I need to do. Well, I have two numbers that are the same value, so I'm going to add these two together. So 32 plus 9, 9 plus 2 is 11, 3 plus 1 is 4, and it is negative, so negative 41 equals negative 41. All right, number 9. Okay, I'm m over 5 minus 8 equals negative 6. The first step you need to do is you need to add 8 to both sides. I'm left with m divided by 5 is equal to, well, I have a negative and a positive, so I'm really subtracting. So 8 minus 6 is 2, and I had more positives, so it's a positive 2. Okay, so up until this point, we've had 8x. We've had 8x, 5x, 3x, 7x, 3x. We've all had multiplication. Now I see m over 5, which this is division. So the opposite of division is multiplication. And I'm going to multiply by 5 on both sides. This 5 over 5 cancels out and it goes to 1. I'm left with m is equal to 2 times 5, which is 10. All right, let's plug it in and check. So I'm going to have 10 over 5 minus 8, and do I get negative 6? Well, 10 divided by 5 is 2 minus 8 equals negative 6. Well, we've got to use keep, change, change again. So keep, change, change. Keep 2, change subtraction to addition. Change 8 into negative 8. All right, I've got two numbers that are two different signs, so I'm going to subtract them. 8 minus 2 is 6. So negative 6 equals negative 6. Yes. All right, number 10. 4x plus 12 equals 48. Well, I'm adding, so now I need to take away 12 from both sides. I'm left with 4x is equal to 36. Divide by 4 on both sides. Goes to 1. X is equal to 9. Let's plug it back in. 4 times 9 plus 12 equals 48. 4 times 9 is 36 plus 12 equals 48. 36 plus 12. 6 plus 2 is 8. 3 plus 1 is 4. 48 equals 48. Yes. All right, number 11. All right, so I have 40 is equal to negative 2 over 5x plus 22. So this time it gave us the x on the right side, but we can still solve it. So I see that I'm adding 22, so I need to take away 22 because I add or subtract first. I am left with negative 2 over 5x is equal to, well, remember, I've got to borrow and carry. 8, 3 minus 2 is 1, so I have 18. If we think about negative 2 over 5 as one whole number, that entire number is being multiplied to x. So I need to divide by negative 2 over 5 on both sides. All right, so I'm going to come down here. So we have 18 divided by negative 2 over 5. Okay, so this is a division problem with fractions. So I need to turn 18 into a fraction as 18 over 1. And I'm going to do keep, change, flip. So I'm going to keep the first term of 18 over 1, change division to multiplication, and flip my numbers. Take the reciprocal. And then how we multiply fractions is we multiply straight across. I'm going to do the easy one first. 1 times 2 is 2. So then I have 18 times 5. 5 times 8 is 40. 5 times 1 is 5, plus 4 more is 9. So I'm going to have 90, negative 90 over 2. And now I need to simplify. How many times can 2 go into 90? 2 can go into 9 4 times with 1 left over. Bring down the 10. 2 can go into 10 5 times with none left over. A negative divided by a positive is a negative. So x is equal to negative 45. All right, so let's go back in and double check. So I should have 40 is equal to negative 2 over 5 times 45 plus 22. Okay, we're going to come over here off to the side because we got to do this section first. Negative 2 over 5 times 45 over 1. Well, negative 2 times 45, 0 and 1. 8 plus 1 is 9. is 90 over 5, and this is still negative. 5 can go into 9 one time with 4 left over. 5 can go into 48 times with nothing left over. And this is still negative. So I have 40 is equal to negative. Did I do something wrong? Hang on. Let me double check my math. 45 times 2 is 90. Divided by 5 is 18. I did mess up somewhere. Hang on. $40 minus 22 is 18. Divided by 2/5 is 45. Okay, so times 2/5, give me just a second, is 18. Oh, that's right. Right here. I was missing a negative because it's x equals negative 45. I was like, why is this not right? So a negative times a negative is a positive. There we go. So positive 18. 40 is equal to, well, 18 plus 22. Now I'm on the right track. 2 plus 1 is 3 plus 1 more is 40. I just forgot my negative sign. Now see what happens when you do forget your negative sign? I had negative 18 plus 22. That would not have equaled 40. That's why I had to go back and double check my math. So 40 is equal to 40. There is a lot of math in that one. All right. Number 12, label each section within the Venn diagram with the correct name of sorting rational numbers. So I have whole numbers, rational, natural, and integers. So I'm going to start from the inside outwards. Well, the first thing that we ever learn, very first, is our counting numbers, which is your natural numbers. These are your positive whole numbers. Okay, the next thing that you guys learn about is whole numbers. You technically learn about it because the only thing in here is 0 in this category. Now, whole numbers does include everything in natural. So notice how your box for whole numbers, it includes everything in natural. So if I had 1 in here, 1 is technically a whole number, but it also is a natural number. Okay, so 1 is both of these. Now, the next thing we learn is integers. These are your negative whole numbers, like -1, -2, -3. And then the very last one is your rational. This is everything. These are numbers that are decimals or fractions. Okay, so what I have down here is I have a list of numbers, and I need to be able to put these numbers into my specific categories, into the lowest category that they can go into. So 0.25. Well, he's not a positive whole number. He's not 0. He's not a negative whole number. He is a decimal. So he's going to go into my rational category. So he goes into rational. You guys don't have to write this, I just am. If you wanted to, that's perfectly fine. All right, -1. Well, he is a rational number because everything in here is rational, but the lowest he can go into is an integer. All right, 0. Well, I already told you guys that the only thing in this box here is 0. Because 0 is not positive nor negative. That's why he gets his own box. All right, I have 104. Well, this is a whole number and it's positive, so it's going to go into my natural numbers. All right, 3 over 4, I cannot write that as a whole number. That is a rational number that's written as a fraction. So he goes into the rational category. Negative 101. Well, 101 is a whole number. It's like a decent one, but it's negative. So that means he needs to go into my integer category for my negative whole numbers. All right, negative 3 over 8. Well, this is a fraction, just like my other one. Even though he's negative, doesn't change that he is a rational number. All right, positive 10, that is another natural number. Okay, I have a whole number and a fraction together, so I have a mixed number, so 6 and 3 over 4. Well, because I have this 3/4 attached to my 6, that makes it a rational number because it is a mixed fraction. That's what those are called, 6 and 3 over 4. All right, 0.3. Now that line right there is actually supposed to be written as 0.3 repeating. That number is a decimal that's going on forever and ever and ever. And this also goes into my rational category of 0.3 repeating. All right, now I have 0.001. I'm still a decimal. So that means I'm still in my rational category. So 0.001 goes into my rational category. Positive 5 ends up in my natural. Oh, sorry, not check, in. Now let's check this one. I have 1,872.0245. Because I have that decimal here, makes it a rational number. So I'm going to have 1,872.0245. He goes into my rational numbers. 1/10 is a rational number because I'm written as a fraction. And then my last one, -2, this is an integer because I'm negative. So this is where all of your numbers should end up. So even though 104, 10, and 5 are all in the natural numbers, they are also considered integers because integers include all the whole and all of your natural. We just put 104, 101, or 10, and 5 into natural because that's the lowest it can go into. But if you're ever asked, is 10 an integer? That is correct because 10 is an integer. It's just the positive, and integers include everything on the inside. Now, if you were asked, is 3 over 4 an integer? You would have to say no because 3 over 4 is a rational number. Okay, same concept. Is 0 an integer? Yes, 0 is technically an integer because it's on the inside of your integers. All right, number 14. Sorry, I was kind of messing around with my class. All right, number 14. When you are adding rational numbers with the same sign, when you are adding rational numbers with the same sign, you add the values and keep the sign. So if I have a negative plus a negative, I'm going to add these two and I'm going to say that it's a negative. If I have a positive adding a positive, I'm going to add them and I'm going to keep the sign of what I have. But in this case, it says when you are adding rational numbers with different signs, wow, that needs to be a D, like a positive and a negative, you're going to subtract the absolute value and keep the sign of the larger absolute value. So that means if my negative was bigger, my answer equals negative. If my positive was bigger, my answer equals positive. Okay? When you subtract rational numbers, you can rewrite the problem to addition and take the opposite value of the second number. Okay? And we're actually about to practice this right down here at number 15. So solve each rational number operation with either addition or subtraction or multiplication and division. Show each step and rewrite as addition problem first if needed. Okay, so I have 1/3 minus 2/3. Well, right off the bat, I see a subtraction. So I'm going to use this statement right here. When you are subtracting rational numbers, you rewrite the problem to addition and you take the opposite value of the second number. Okay, so I'm going to use, and we've already used it before, keep, change, change. I'm going to keep the first term of 1/3, change subtraction to addition, and I'm going to change the value of the second term and take the opposite value of the second term. And originally it was positive, so now it's negative. Okay, then I have two numbers. I have 1/3 plus negative 2/3. Well, I have a positive value and a negative value. So just like right here, when I'm adding with two different signs, a positive and a negative, I need to subtract my two numbers. Well, I can go ahead and do that since they both have a common denominator. So I'm going to do 2/3 minus 1/3 is equal to 1/3. Okay. And then I look at which value was bigger. So negative 2/3 was larger. And I take the value of the larger number, which is the negatives. I had more negatives than positive, meaning my final answer is negative 1/3. All right, look at number 16. I have a negative plus a positive, negative plus a negative. I have a negative plus a negative. So I have two of the same sign, so I'm going to add them. So 7.6 plus 2.4. Now remember, when adding decimals, you must line up your decimals. 6 plus 4 is 10. Carry the 1. 7 plus 2 is 9. Plus 1 more is 10. Bring down the decimal. Well, it's a negative plus a negative. Well, my final answer has to be a negative, and it is negative 10. All right, number 17, negative 1/5 minus 2/10. All right, so I got to keep, change once again. So keep the first term, that was negative 1/5, change subtraction to addition, and then change the value of the second term, which is negative 2/10. Okay, well, I cannot add my two fractions yet. They have to have the same common denominator. And what's common between 5 and 10 is 10. So I need to multiply my fraction on top and bottom by 2 to get 5 into 10. Well, this negative still stays, so I have negative 2 over 10 plus negative 2 over 10. Now I can add my fractions straight across. Negative 2 plus negative 2 is negative 4 over 10. Well, we can simplify this because I can simplify it by 2. 4 divided by 2 is 2, and do not forget that it's negative, over 10 divided by 2 is 5, and negative 2 over 5 cannot go any smaller. All right, number 18. I see another subtraction, so I'm going to do keep, change, change. Keep the first term at negative 8.5. Change subtraction to addition, and change the value of positive 2.1 to negative 2.1. We'll have a negative plus a negative, so now I'm going to add my two numbers because I have two of the same signs. Remember, line up my decimals. 5 plus 1 is 6. 8 plus 2 is 10. And this is negative, so my answer is negative 10.6. All right, so it looks like for number 19, we have to do several things. So the first thing, let's go ahead and change this to an addition problem. So I'm going to do keep, change, change. So I'm going to keep 5 and 1/3. Subtraction changes to addition. And I'm going to change the value of this. And right now it's negative. So I'm going to change it to positive. Okay, so I have a positive plus a positive. So I'm going to add everything. All right, so let's line up our fractions. 5 and 1/3. Let's actually stack them. And 2/5/6. And we are adding these. So when you stack your fractions, remember we have to add our two small fractions first. So 1/3 plus 5/6. Well, I can't add these two yet. I have to find a common denominator, and it looks like 6 is common between 3 and 6. So I'm going to multiply by 2. So I'm going to have 2/6. Now I can add 2/6 and 5/6. Well, 2 plus 5 is 7/6. 5 plus 2 is 7. Well, now I cannot have a mixed number inside of my little fraction here. So I've got to reduce this here. I know that 6 can go into 7 one full time with 1/6 left over. So I need to add 1 full to this 7 to make it 8 and 1/6. All right, so we got some more problems going on. Alicia had negative $11.15 in her checking account. She did a few chores and made 42. She decided to pay for herself and a friend to go to the movies, and each ticket cost $6.50. How much money does she have left in her account? Okay, well, she started with a negative balance and she added 42. So I need to subtract what she added from her negative balance. Because when you add money into a negative account, it's going to take out, they're going to take away this and they're going to be left with something. All right, so I need to borrow and carry. This goes to 1, sorry. 10 minus 5 is 5. 9 minus 1 is 8. Decimal, 1 minus 1 is 0. 4 minus 1 is 3. Okay, so she had $30.85. Okay, after she added the 42 to take care of her negative balance, she has $30.85. Her and a friend go to the movies, where each ticket costs them $6.50. So there are 2 people going to the movies, and they need to buy 2 tickets. So 2 times 5 is 10, 12, and 13. 2 place values. So it's $13 for both of them to go to the movies. How much does she have left in her account? Well, she offered to pay, so we have to take 13 away from her balance that she has. So remember, you must line up your decimals when you're adding or subtracting. 5 minus 0 is 5. 8 minus 0 is 8. Decimal, I cannot do 0 minus 3, so I need to borrow and carry. 10 minus 3 is 7. 2 minus 1 is 1. So her ending balance, after she did some chores and after she bought her and her friend a ticket, she has $17.85 left. All right, number 21. Suppose the Rocky Mountains have 72 centimeters of snow. Warmer weather is melting the snow at a rate of 5.8 centimeters a day. If the snow continues to melt at this rate, after 7 days of warm weather, how much snow will be left? Okay, well, first step I need to do is I know it's 5.8 centimeters a day, and I want to know after 7 days how much snow is going to come off. So I need to do 5.8 times 7. Well, 8 times 7 is 56. 6, carry the 5. 7 times 5 is 35, plus 5 more is 40. Move my decimal 1 place. So after 7 days, 40.60 centimeters melts. But that's not the answer. It's saying how much snow will be left. So if I start with 72 and 40.6 centimeters has melted, what do I need to do with my two numbers? I need to subtract my two numbers. So I need to do 72 minus 40.6. Whoops, 8 times 7. Double check my math. Yep. Now, with 72, you have to add a decimal and a 0. So we can borrow and carry. 10 minus 6 is 4. Decimal, 1 minus 0 is 1. 4, 5, 6, 7. 7 minus 4 is 3. I had to do some quick mental math to see that you have 31.4 centimeters left of snow. All right, number 22. A bakery bought 225 pounds of baking powder. It used 6.8 pounds per day. How much did the bakery have left after 3 days? Okay, well, first I need to find out how much do they use in 3 days. So for 1 day, they use 6.8 times 3. Well, 3 times 8 is 24. 3 times 6 is 18, plus 2 more is 20. I have a 1 place value, so I'm going to move it 1 time. So in 3 days is 20.4 pounds used. So if they started with 225 and they used 20.4, how much is left? So I need to subtract 225 minus 20.4. Add a decimal and a 0. 10 minus 4 is 6. 4 minus, bring down the decimal. 4 minus 0 is 4. 2 minus 2 is 0. 2 minus 0 is 2. They will have 204.6 pounds left. All right. The Macon Middle School Field Day uses a course that is 7.5 miles long. Each runner in a team of 6 will complete that's not let, that's supposed to be leg of the relay. How far will I really misspelled this, team member run? So they're going to each complete an equal amount of the leg. So if there are 16 members, I want to know how far will each member need to run. So I need to divide this. So I need to take how much I run, divide it by the number of people that I have. Okay, so I got to do one thing first. I need to turn this mixed number into an improper. So I need to multiply the denominator by the whole. So 2 times 7 is 14. Then add the numerator, which is 15 over 2. Divided by, well, let's go ahead and take 6 and turn it into a whole number of 6 over 1. And now we can do keep, change, flip in our fraction. So 15 over 2 times, flipping this, 1 over 6. So I'm going to have 15 over 12. Okay. We can reduce this by 3. 15 divided by 3 is 5. 12 divided by 3 is 4. And now we can turn this fraction here into a mixed number. 4 can go into 5 one full time with 1 left over, and my denominator is still 4. So each member will run 1 1/4 miles. Okay, number 24. The current temperature for the past 8 hours has been changing at a rate of negative 1.5 centimeters each hour. The current reading is 0 degrees. So right now we're at 0. Okay. What was the temperature reading 7 hours ago? So prior to the current reading. Well, first off, if I'm changing 1.5 each hour, I want to know how much did I change in 7 hours? Let's set this up this way. Okay, so 7 times 5 is 35. 7 times 1 is 7, plus 3 more is 10. I have a 1 place value. So I have this, which is 10.5. Okay, so here's where this gets a little tricky. So it is decreasing because I'm getting colder. Okay, I'm getting colder, so I'm subtracting 1.5 every single hour. I want to know 7 hours prior to my current reading. So if my current reading is 0, and this is how much I changed over the course of 7 hours to get to 0, we need to actually add this back to 0 to 7 hours prior was 10.5 degrees. So taking a look at letter B, it's saying, what is the temperature predicted 6 hours from now? So if I start at 0 degrees, I'm going down. I'm getting not colder. And I'm doing it by 1.5 degree for every hour. So 6 times 5 is 30. 6 times 1 is 6, 7, 8, 9.0. So I need to do 0 minus 9 is negative 9 degrees. All right. When was the temperature reading at 6 hours? So I need to take my 6 and I'm going to divide it by how much I'm changing. Because I know that it's 1.5 for every hour, so I need to do 6 divided by my change. Well, I'm going to have 1.6 on the out or 1.5 on the outside, 6 on the inside. I cannot have a decimal on the outside, so I need to move my decimal 1 time. Do the same thing on the inside. Move it up, add a 0. So now I have 15 divided by 60. So if I think about it, I have 15, 30, 45, 60. Well, 15 can go into 60 4 times. That means when was the temperature reading? It was 4 hours prior. When is the temperature expected to be negative 9 degrees? Well, I'm going to do the same thing. Negative 9 divided by 1.5. So I have 1.5 on the outside, 9 on the inside. Move our decimal yet again. Add the 0. So 15, 30, 45, 60, 72. Right? No, 75. Wow, sorry. And then that should be 90. So 1, 2, 3, 4, 5, 6 would get me 6. And then for it to be negative 9 would be 6 hours from now. All right, and then the last 4, it's asking us to answer true or false and then justify the answer. If it's false, give an example of when the statement is true. Okay, the sum of 2 negative integers is always a negative. This is true. So think about it. Negative 2 plus negative 3, I'm still going to get a negative. Negative 4 plus negative 10, I'm still going to get a negative. That will never change. The product, which means to multiply 2 negative integers, is always a negative. This is false. A negative times a negative is a positive number. So like negative 2 times negative 3 is positive 6. It will never be a negative. Okay, the sum of an integer and a negative integer and a positive integer is always positive. False. And here's why. So if I have negative 2 plus 8, okay, that answer is a positive 6. Okay, so that fits the category. But if I had negative 8 plus positive 2, well, negative 8 plus positive 2 is 6, but I have more negatives. So my answer is negative 6. So not all the time is a negative and a positive added together going to give me a positive. It depends on which number is larger or has more negatives or more positives. And then the last one, the product or multiplying a negative and a positive is always a negative. And this is true. A positive times a negative is always going to give me a negative, or a negative times a positive will always give me a negative. Like 2 times negative 3 is negative 6. Negative 3 times 3 is equal to negative 9. If you have any other questions, please let us know.